Hi everyone. Good morning, good afternoon, good evening, wherever you might be. Thank you so much for tuning in. My name is Abhishek Gupta. I am a developer advocate here at Microsoft, where I tend to focus on open source technologies such as Apache Kafka, databases, and Kubernetes. My Twitter handle is right here, if you can see that. So please feel free to connect with me. So for today, the agenda is really quite simple. I will kick off with a presentation, the one which you are looking at right now. But don't worry, this is still going to be a hands-on workshop. But given the fact that some of the technologies I'm going to talk about are still relatively new, I think getting an overview will be helpful when we walk through the workshop and you try to connect all these dots together. And after this presentation, like I said, I will dive into the more practical examples with the workshop. Now, this is all going to be about near real-time analytics with Azure Synapse Link for Azure Cosmos DB. Now, I know that it is quite a mouthful, but really the goal here is to provide you with practical introduction to both Azure Synapse Analytics and Azure Synapse Link for Cosmos DB. Now we can only cover so much during a space of about 45 to 60 odd minutes. So I really encourage you to use this as sort of a stepping stone or more of an icebreaker, so to speak, right? And then when you go back, you should be able to make sense of it all, hopefully. And for those of you who might already be working with these technologies, and if you're familiar with them, that's awesome. I really hope this proves to be a good refresher for you, right? Now, like I said, here is the agenda, pretty short, pretty simple. I'm going to go through Synapse Analytics and Synapse Link. And this is important. Before I dive into the meat of the workshop, these are a few important resources which you should definitely know about. First is the workshop guide. So this is a step-by-step guide which I've created. This is on a GitHub repo. The link which you see is a short link, aka.ms/cosmosdb synapse workshop. Hopefully that should be simple enough for you to remember, but don't worry, this is going to be all dropped in to the live Q&A section as well, so you can refer to that later. And of course, the official labs which have been heavily reused for the purposes of this workshop as well. So this has been released by the Cosmos DB product team. So that's available at aka.ms/cosmosdb synapse link samples. All right, so let's get right to it. So let's back off a little bit and think about what life was before this thing called Synapse Link, right? Now, if you are familiar with Azure Cosmos DB, it is a multi-model database which offers you a variety of options. One is the core SQL API, but in addition to that, it gives you these open source APIs as well, such as Cassandra, MongoDB, and Gremlin for Graph, right? So typically what developers and companies and teams do right now is they tend to use the same database or the same container, irrespective of whichever API they are using, in order to run two very different workloads, OLTP and OLAP. So it stands for transactional and analytic workloads respectively, right? And what happens is that these applications and services they put in data into the transactional store, and teams use technologies such as Spark or any other platforms to be able to run analytics on the same workload, right? Now, there are some issues which come along with this approach. Now, this impacts performance since you're using the same database for very different workloads, right? You won't be able to, say, archive your transactional data because you're going to need it for analytics purposes, right? So this, all in all, it results in the fact that your costs, latency, and performance requirements, they all rise up as your data and data volumes grow, right? Now you could adopt a separate approach, right? And teams do that. You can separate out these OLAP and OLTP workloads, but then remember, right? You'll have to work on building those ingestion pipelines, those data pipelines to push data from Cosmos DB to something like a data lake, right? And this is and from this data lake, you're going to have this is going to be a periodic or say batched ingestion process. And this is now going to result in things like reporting or insight generation suffering from delays, right? So the way Azure Cosmos DB has attempted to solve this problem is by adopting a so-called hybrid approach, right? Something which is called as HTAP, hybrid transactional and analytical processing. I know, again, this is sort of a mouthful, but in simple terms, building applications on top of Azure Cosmos DB is just one half of the problem. On the other half, customers are expecting to be always able to use the data present in Azure Cosmos DB to be able to generate rich insights, right? They want to deliver analytics over operational data at literally real time, right? Or near real time. And this is for a variety of purposes, starting from predictive analytics, doing machine learning, fraud detection, so on and so forth, right? And this is exactly where Azure Synapse Link for Cosmos DB comes into picture, because it tries to, or rather it has broken down the barrier that long existed between these two types of workloads, the OLTP and the OLAP workloads, right? So what it is that it's a cloud native capability that enables you to run analytics over transactional and operational data within your Azure Cosmos DB databases with almost no ETL and the performance impact on your transactional workloads. Remember the cons which I was just talking about a couple of slides earlier. Those cons no longer apply, at least most of them no longer apply when you use something like Azure Synapse Link, right? Now the question is, what's the magic all about? How does it really work behind the scenes, right? So like I said, all your operational data in Cosmos DB is internally stored within what you call a row-oriented transactional store, okay? Now this is optimized for transactional reads, writes, and all those operational queries. So this is something which customers and developers have been using, right, since the very beginning of Cosmos DB. Now, in addition to that, there is now a fully managed native analytical store within the same Cosmos DB container, right? Now, this is more of a column-oriented store as opposed to the row-oriented store, which the transactional capabilities use. And this column-oriented store is optimized for analytical queries over large volumes of data, right? So all your inserts, updates, and deletes to the row-oriented or the transactional store are now automatically synced to your analytical store. It's not instantaneous, to be very, very honest with you, and to be realistic, but it is near real time is what you would typically call it, right? And the good part is that this auto sync capability does not consume any RUs or request units, which are the typical, which are the sort of currency of judging your pricing within Azure Cosmos DB, right? So you don't pay for this auto sync capability at all, right? And what now happens is that Azure Synapse Link sort of builds on top of this analytical store. And once the data is in that analytical store, you can query Cosmos DB using technologies such as Spark, Synapse SQL, and at the end of the day, you can use this to build things like machine learning pipelines, big data analytics, real-time BI dashboards, and it's the solutions are really restricted only by your imagination, right? Now, this analytical store is supported right now for the Core SQL API and the Azure Cosmos DB API for MongoDB. All you need to do is really just turn on a configuration parameter within your Azure Cosmos DB account, as well as make sure that you turn this on explicitly on every container which you create within your database. Don't worry, we'll go through all these things when we are during the course of our hands-on workshop anyway. So the TLDR is that it is super easy to be able to just turn it on. It's a turnkey solution, so to speak. And if you think about this concept of time to live. This is really so for your analytical store, in order to be able to save costs or for it to be cost effective, the data retention period or time to live for your analytics data is completely tunable, right? So these are the options. If you see this table, you could choose, to turn off, your analytical store. That's fine, right? If you want to retain it infinitely, you can do that, or you can have like a precise value saying, hey, I want to make sure that items from my analytical store expire after 60 seconds, right? So it's completely tunable for you to be able to decide how you want to leverage it and ultimately at the end of the day manage your costs. Now, I just told you that it is supported for the core SQL API as well as the MongoDB API. Now, there is not a lot of difference in terms of how it is supported. It's the same thing, right? Essentially, now you can run, your Spark queries and Synapse SQL queries for all the transactional data within your MongoDB containers, right? Within the Cosmos DB. But there is one thing which I definitely want to draw your attention to, and that is this concept of a well-defined versus a full fidelity schema representation. Okay. Now, just to summarize this, in a well-defined schema, you have properties which are always the same across multiple records or items within your database or container. Okay. But in the case of full fidelity schema, it is a little more flexible. So, different entries or records within your database may have different data types. Now, you might find this weird, but if you look at this example, for instance, pay attention to the purchase data property here. Now, on the record in the left, it is a string, but on the record on the right, it's a timestamp. Similarly, if you look at the array product vector, there is a difference there as well. So the important thing for you to understand right now that dealing with full fidelity or well-defined schemas has an impact on how your data is actually structured or stored within the analytical container, right? So in terms of support, the well-defined schema is your default option as far as the core SQL API accounts are concerned. So what happens in this case is when you enter or ingest that first record or that first document within the container, that sort of defines the schema, right? And if you have other documents or records which don't adhere to that schema, they will not be synced from the transactional to the analytical store. But it is slightly different or completely different for that matter in case of MongoDB API, because the full fidelity schema is the default option here, right? So you have a lot of flexibility. So for example, if you have two records, so if you see here in one document, you have the status as 1, which is represented as a string, and maybe on the other one, it's an integer. So within the analytical store, the column names will be actually appended by the data type. So in this case, it is status.string, or in the case of integer, it will be status.int32, for example. Okay. The details obviously are available in the documentation, but here is a quick snapshot, sort of a mapping of all the properties and data types and how they are represented in the analytical store. Now, this background information is important because there is a workshop notebook which I will go through during our hands-on session as well. Now let's talk about, I'll give you a quick overview of Azure Synapse Analytics, because to be very honest with you, it's not possible to cover Synapse in a slide or two, or even I think 20 to 30 minutes. It's that fast. But what I can tell you is that it is really becoming the hub, and it is set to integrate with a lot of services and databases within Azure and as well as in the open source ecosystems and external cloud providers as well, right? So it is sort of going to be the central point where you bring in all the data and then use Synapse Analytics to crunch all that data. So if I were to sort of peel the layers a little bit, so at the very bottom, you see that there is, solid data lake integration, and then you have all the common, so to speak, cross concerned services like management, security, monitoring, so on and so forth. And you have a couple of options in terms of which analytics runtime you want to choose, right? Is it Synapse SQL or Apache Spark? Now, this is something which I will go through during the hands-on workshop as well. And these capabilities are available to you in different flavors. So you could opt for a serverless SQL pool or maybe a dedicated SQL pool, for example, right? And again, it has polyglot language support. And if you are so inclined, it has sort of a code-free, or I like to call it a low-code option in the form of Synapse Analytics Studio as well. So that's sort of a quick summary or the lay of the land, so to speak, as far as Synapse Analytics is concerned. Now, how what are the options available to you? Like I was saying, you have Synapse SQL and Apache Spark. Now, which Apache Spark, excuse me, it's quite simple, right? So what you could do is simply refer to or link up to an existing Cosmos DB database using a linked service. I'm going to demonstrate that during the workshop. And then you can use Spark data frames to load, for example, batch data, things like CSV files, or ingest streaming data from a system like Apache Kafka. And then you can do some processing on it and finally write this data into Cosmos DB containers using the OLTP integration within Synapse, right? So I'm talking about the transactional store, the row-oriented store within Cosmos DB. And like I said, this data is going to automatically get synced into the analytical container. And once that is done, you can use Spark SQL to further analysis, things like aggregations, joins, so on and so forth. And I'm going to demonstrate that to you as well. And as far as Synapse SQL serverless is concerned, Synapse SQL in general gives you the ability to do T-SQL-based analytics, and it has two consumption models, as I alluded to earlier as well. So it has a dedicated as well as serverless mode, and you can essentially create things like views or run T-SQL queries against your to access your Cosmos DB data, and you can do a bunch of things. Example, use the integrated Power BI to to run real-time dashboards and so on and so forth. So really, there's a rich set of capabilities which you can leverage with Synapse SQL as well. So how do you actually make that happen? And I am going to run through this anyway during the course of the workshop, but I want to quickly show you a snapshot. So you go to your Synapse workspace, say, hey, I want to create this linked service to associate to Azure Cosmos DB. You choose your subscription and all your details, database, account names, so on and so forth. And boom, that's pretty much it, right? Now you can use Spark or Apache Spark or Synapse SQL to crunch your data. Before I move on, I want to highlight once again that these are key resources which you definitely want to check out later on. One is the workshop guide, the one which I'm going to use right now in a few minutes to run you through the entire workshop. And the other one is the official labs, which is built by the Azure Cosmos DB product team, which I'm sure you're going to find very helpful when you sort of want to check out some of the advanced scenarios and more involved use cases, right? So yeah, thank you. But then the show is going to continue. I'm going to end the slideshow and hop over to my browser, and hopefully you can see this all well and good. So this is the GitHub repo which I was referring to. You can access this, like I said, using the short link which is posted in the live Q&A. I'll just pause for a quick break here. Excuse me. All right, so I'm in the workshop repo right now, and like I said, this heavily leverages some of the existing notebooks from the official samples repository, as pointed to here. Like, why reinvent the wheel, right? So yeah, it is going to cover things like, of course, some of the basics of Cosmos DB, and of course how it integrates with Synapse Analytics using Azure Synapse Link. I'm going to walk you through some of the basic operations like, looking at, Cosmos DB containers, database accounts, and the Synapse Analytics environment. And the scenarios, and this is the important bit, right? The scenarios, the practical examples which I'm going to demonstrate are these. So the first one is going to be an example where I will be ingesting batch data in the form of CSV files, right? And then what I'll do is use this data to perform certain aggregated operations across multiple Azure Cosmos DB containers, right? So that's key, right? So the beauty here is that I'm going to be using just one platform, one place, and you'll see that real quick to be able to query data and join them and mix and match them, which is spread across multiple Azure Cosmos DB containers. Okay. I'm going to walk you through an example of streaming ingestion as well. So this is, as opposed to batch data, this is real-time data which is continuously being generated and how you can handle that. And as I promised earlier, I will also demonstrate an example as to how you can use the MongoDB API for Cosmos DB and how does that work with Synapse Link. Now, you have obviously seen this diagram before, so I need not waste time covering this right now. And I have highlighted some of the learning materials and resources in case you want to, not in case you, I'm really hoping you go back and learn, spend some time, learn some of the foundational concepts. So, and I'm hoping that these resources might be helpful. And, this repo will most likely be updated with other, resources and contents and maybe bits and pieces of corrections here and there as well. So this is going to be a living example, and hopefully you're going to be able to benefit from that. All right. So the prerequisites. Now, what I have done, in order to be conscious of your time, we have only about 45 to 60 minutes. I have finished most of the steps in this particular section here, right? So, but I'm going to walk you through it still, So the Azure Cosmos DB accounts and the related resources. Okay. So let me go to my browser. I hope you can see this. So right now you're looking at the Cosmos DB SQL API account, which I have, which is called Data Week, appropriately named Data Week Cosmos, right? So this is the SQL or the core API. Okay, and the important thing is that if you look at these settings section here and notice that I've already switched on the feature which enables Azure Synapse Link, right? So the status in this case is on. So like I said, this is literally a turnkey feature. So this is switched off by default when you create a new Azure Cosmos DB account or for your existing Cosmos DB accounts. So you can definitely hop in and simply with the click of a button, you can turn on this particular feature. If I were to go into the Data Explorer section here and just wait for everything to come up. So if you see that this is the SQL API, and I have one database called Retail Sales Demo DB, and it has 3 individual containers to be able to store data. So later on, I'm going to show, when there is data in these containers. Right now, you can be doubly sure that these are empty, and only when I, run operations through Synapse Analytics, only then will these containers and collections be populated. So just so that just keeping myself honest. So that's all I wanted to show you in terms of the SQL API. The same goes for the MongoDB API as well. So I have a MongoDB API account created here, and the same is applicable to this account as well. I have made sure to enable the Azure Synapse Link feature, and if I were to go into the Data Explorer here, you will see that I have a database and a collection already created. So if you see, HTAP might be confusing, but it's not super intuitive. I apologize for that. But HTAP is the name of the collection, while Demo Synapse Link MongoDB is the name of the database. Now, mind you, I did not mention this for Cosmos DB API, but again, just to remind you that you have to explicitly switch on the analytic container feature for each container or collection you create as well, in addition to the account level setting, right? So if you see here, analytical storage is turned on, and I did that explicitly when I created this collection. All right, that's it in terms of the Cosmos DB related resources. So now I have hopped into my Synapse workspace, yeah, it has an associated data lake storage account, ADLS Gen 2. And what's important for you to know is that I have something called an Apache Spark pool, which is pre-provisioned. I have a, this is for the sake of demonstration. I have a small node here. It's called Data Week Spark, and yeah, just to make sure that you know and understand that these resources have been created in advance. And another thing which I wanted to point out, and I might repeat that when I'm running that specific notebook, is the fact that I have added or uploaded additional packages to this particular Spark pool, and I'll let you know what those packages are. But just so that you know, you can, for example, if your PySpark code is within Synapse workspaces or notebooks is using some custom libraries or third-party libraries, you can you have to make sure that you upload that in form of a requirements.txt and upload that to your Spark pool. All right, that's it in terms of a quick walkthrough of Synapse. And now what I'm going to do is hop back to my README right here. So I have gone through all these things, Azure Cosmos DB, the core account, the MongoDB account, so on and so forth. And same goes with the workshop setup, right? Now what I'm going to do is go to my Azure Synapse workspace and walk you through some of the configurations there as well. Okay, so what you see right now is the Synapse workspace. This is the home page. Now, if I were to go into this data section right here, you will see that there are a couple of entries here. Okay, and notice that these are linked resources. Okay, so one is Azure Cosmos DB. Now, this is nothing but the Cosmos DB account, the same account which I just showed you, right? So what I've done in advance is created this linked service, so to speak. So I can actually go through the process, just show it to you real quick, right? So if you were to click on this plus icon here and choose connect to external data, so these are the options available to you right now. These are obviously going to increase in the near future, and choose, for example, the in this case the SQL API. Click on the continue button. And if you were to choose the appropriate Azure subscription, in this case, it is still loading. So I'm going to give this a bit of time. But yeah, so if I were to say, for example, choose my subscription and choose my Cosmos DB account, in this case, I have chosen the SQL account, of course, and choose the appropriate database. This is the same database which I just showed you, and say, hey, all right, and I can test the connection and all is good. I'm not going to click create because, of course, I have already created this linked service. I'm going to cancel this right now. And I also want to highlight, like I mentioned earlier, there is a data lake storage account which is associated with your Synapse workspace, right? So this is also a linked service, so to speak. Now, one of the steps which has been mentioned, if I were to go back real quick here, is for the first notebook or the first example to run, we will have to upload some CSV files to this storage account, right? So I already have this CSV files uploaded. I'm going to show them to you real quick. And let me open this storage account. and the file system associated with this account. So if you see, if I were to go to the root file system, I can show you that I already created a folder called retail data. And if I go into this, I have 3 CSV files. These are going to act as batch data, which I'm going to import or ingest pretty soon. So I'll really quickly go into my VS Code and show you actually what are the contents of the CSV file. So the first one is products.csv. This just contains, this is obviously random data, right? We are just dealing with 3 products. For example, this is like a retail scenario. So we have 3 products here, right? Surface.go, Surface.pro 7, and a Surface laptop. These have IDs and they have wholesale cost associated with them, right? So just 3 products, keeping it very simple. Now we have another CSV file which captures the store demographics, right? Things like, the income, and there's really lots of information there. As you can see, there are a lot of columns right here, right? So this contains or captures the store demographic, the demographics associated with individual stores, right? So you can see there is a different store is represented by a different store ID. And finally, the most important of them all is this retail sales demo, which represents like, sales data, right? Which is coming through essentially on a weekly basis, right? So you have that store ID, the product code, the quantity, the price at which it was sold, starting week, so on and so forth, right? And the ID, and it has, I think this has about 25,000 rows. Let me scroll down real quick. Yeah, about 29,000 rows approximately, right? So these are the CSV files which we are going to work with for the purposes of this demo. Okay. Now, having said that, I'm going to now jump into the first scenario. Now, I have already imported or completed some of these steps, and that is just one simple step. I have downloaded a particular notebook and imported that within my Synapse workspace, right? And I have given you very clear instructions, so it should be very simple and intuitive for you to do that as well once you're trying this at your own pace. So this is if I were to quickly go into the develop section here. So if you see, if I click on the plus sign, you have the ability to import notebooks if you were to click on this button. But because I have already imported these notebooks, I'm going to not do that. OK, so this is the notebook. There's a lot of information, background information here in terms of what the use case or the scenario is. But like I told you earlier, I'm not going to run you through all these steps, right? Or this information is something which you can obviously digest later on, but I'll walk you through the important bits real quick. So I'm going to scroll down here and go to the important bits. So let me just remove this. And I hope this is big enough for you. If not, I'll just bump up the font here. So first things first, right? We are going to import data from these CSV files. Now, if you remember, I showed you the folder and how the CSV files are stored. They are stored in a folder called retail data, right? So once I click on this once I run the cell, what's going to happen is that this data is going to be stored into this Spark data frame called df store demographics, and these individual data frames for these individual data categories for product, retail sales, and store demographics, right? So as you see, command executed in 2 seconds. All my jobs are available. You can see the status here: succeeded, all good, perfect. Moving on. Now, what are we going to do now? So we have this into a data frame. Now, what we are going to do is write this data into the Azure Cosmos DB container. Now, this is the row store or the OLTP, the transactional store. Remember this. This is not the analytical store, right? Because so just a quick tip here. So the cosmos.oltp, which you see right here, is nothing but the Spark format, which enables you to connect to the transactional store, right? And all the operations, the ingestion operations, are done against the OLTP store, not against the analytic store. The analytic store, the integration between the OLTP and OLAP store is, like I said, it's auto sync. right? It just automatically happens behind the scenes. Nothing for you to worry about. OK, so if I were to click on this run cell, so if you see, this is going to refer to this linked service, the one which I just showed you. This is going to give this a handle to the Cosmos DB account, and it knows the container it is working with. And this applies to all the three containers, right? The demographics, retail sales, and products. OK, so let me run this cell real quick, and let's see what happens. So let's see what's going on here. I should be able to see the progress. One of the jobs has been succeeded. By the way, you can click on this and dive in. I'm just avoiding that to avoid, just prevent lots of context switches. So yeah, that's pretty much. So this is now complete. Now that's pretty much it in terms of this notebook. OK, so let's go back and double check here, right, and refresh and see if the data has now been ingested. So you see that this is, I'm looking at the, again, just to repeat, this is the row store, this is the transactional store. OK, so the product data has been inserted, all the retail sales entries, all the 29,000 odd entries, they are present here as well as the demographics information for all the individual stores. Cool. So far, so good. Things are working. Now let's move on to the other notebook. So I'll quickly hop back just to make sure I'm in line with all the instructions, because I'm assuming you will follow this later on as well, right? So I just completed the batch data ingestion. Now what I'll do is I'll open up another notebook. Again, the instructions are very clear here, and show you an example of how to join data across these individual containers, right? Three individual containers within Cosmos DB. Now, just to let you know, this notebook is actually, if you look at the high-level scenario, this is a machine learning, forecasting scenario. Just give me a second, sorry, just to make sure I'm in the right notebook. Yeah. All right. So this is a Azure machine learning scenario, but we are not going to deal with that right now. What we will do is just give it a little bit of time to for the Spark session to start. It can take maybe a few minutes. I apologize for that. So in the meantime, what I'll also do is make sure that the other session has also started. Don't worry about what I'm doing. I'll go through these steps real quick here. Yeah. So while the Spark session starts, let me just walk you through what I'm going to do here, right? So now the data is within the row stores or the transactional stores. Now what I'm going to do is analyze them. This has also been auto-synced as we speak, hopefully, within the analytical store as well. OK, so what I'm going to do now is use Spark SQL, as I demonstrated in the PPT earlier, to be able to join and aggregate some data. So we are going to all right, it seems as if the Spark session started real quick, which I'm very, very happy with. So we are going to create these intermediate views or metadata tables using Spark SQL, right? So we'll start off by creating a database called Retail Sales Demo DB. Now, I apologize for the naming scenario, the naming convention, sorry. It is the same as the name of the Cosmos DB database. But I do want to highlight that this is a Spark SQL database, which I am dealing with right now in the context of this notebook. OK, just to make that clear. Now, once I have created this database, I can create those individual tables as well, right? So starting with the retail sales table, that's done. Run this cell to create the store demographic tables, right? This is going to, yeah, and finally create the product table as well, right? So again, just highlighting, these are Spark SQL tables, OK? Now, if you look at this rather, well, it's not that bad. There are a lot of columns which we are trying to show up here in the result. But I'm going to run this and then walk you through this. Now this is a join across, like I said, 3 different containers within the same Azure Cosmos DB database. So you see it is against retail sales, product code, as well as store demographics, right? So we are doing, hey, select from the retail sales database and left join it with the product database on the product code and left join that to the store demographics. This is the result. Let me complete this. Left join that to the store demographics table on this time using the store ID. Okay, and then you order it. So I've just limited this to 100 rows. And if I scroll down to show you the result, which I just obtained, you will see that this is the result. I know, like I said, there are a lot of columns here, but that's not important. You could obviously pick and choose. Now, there are so many columns because, like I said, this notebook is actually a scenario for Azure machine learning forecasting, right? I am not going to go through all these cells. These are for you to obviously go back, do your homework, and run through this. These are very interesting use cases, but they are, to be very honest with you, time consuming, and I cannot run it to completion within the scope of, say, 15 to 20 minutes. So definitely encourage you to go back and check how to use AutoML to build up a forecasting model. There are different cells here which are related to data preparation and training the models and so on and so forth, right? So yeah, just go back, try it out. Okay. So far we have ingested batch data, and I showed you how you can join analytics, the data within your analytics database, analytics store within the Azure Cosmos DB container using a simple Spark SQL query from Synapse Workspace. Now, hopping back, we just finished the first two scenarios. Going back to the third one, and I'll just walk you through this one. I'm not going to run this. Now, this is about streaming ingestion. This involves a different notebook. You can download, import that, run that to your convenience. Now, I'm going to run you through this. Now, imagine you had IoT data from sensors, right? So in ideal scenarios, you will use something like, say, Azure Event Hubs or Apache Kafka to ingest that data. Now, what I've done for this example is use just a sample rate streaming source generator with Apache Spark to generate this data, right? Now I have this stream. Now using this stream, what I can do is generate some sample IoT data, right? So once I have that data, what I can do is now stream these writes to these Cosmos DB collections. Now, everything is pretty much the same. What I just showed you for the batch ingestion notebook, it is the same. The only thing, the only difference is that this is a streaming query, right? So this is like a continuous query which runs either forever or for the amount of time you want it to run, right? So it can run forever and keep on ingesting data from your source, which could be Kafka, Event Hubs, or any data generator for that matter, and keep writing them into Cosmos DB containers, right? So that's the concept as far as the streaming ingestions are concerned. Now, hopping back into the guide once again. Now I'm going to walk you through a MongoDB notebook, okay? And I will talk you through the concepts which I had previously mentioned, this concept of well-defined schema versus full fidelity and how that works when you use the MongoDB API within Synapse Link, right? So let me go back into that notebook real quick here. All right. Yeah, so all this is done. We have created the the MongoDB collection database, all good. If you remember, I mentioned earlier that this particular notebook uses additional Python libraries, and I made sure that I captured that in the form of requirements.txt, and it is uploaded into this particular Spark pool for this notebook to work. Okay, so first things first, I'm just going to make sure that it has indeed been imported. So if you see, hey, okay, this is using PyMongo and enum. These are imported, all good, right? So we are good there. Now, In this case, this is simply adding. I've just set these particular variables to my the database, the MongoDB account name, as well as the primary key. Don't worry, it will be recycled after this workshop, as well as the database and the collection names. OK, now what I'm going to do is initialize the MongoDB client. So this is using the PyMongo, the PyMongo library to ingest or push data into MongoDB collections within Azure Cosmos DB. So I'll make sure I initialize that. That's done. All good. If I scroll down, now what I'm going to do is run this cell. And it's going to just generate random sample data and insert 500 items within my collection. Now, if I were to quickly, just real quick, hop back to my MongoDB collection right here, just to make sure, in case I didn't do it earlier, there are no documents in this particular collection right now, if you notice, right? And let me go back to the workspace here real quick. Now, what it is simply doing is it is getting hold of this HTAP database, and it's going to, these are the items which it will select at random, pizza, sandwiches, blah, 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 generate pickup items, generate random prices, and generate a timestamp. This is important. Just make a note of it for now. This is going to generate a timestamp for this timestamp data type for this timestamp attribute. OK, so let me run this. Running. All right, it says finished creating orders, executed in 9 seconds. Let's go back to our collection here and double check if how things went. OK. All right. Yeah. For a second there, I was concerned. All right. So 500 entries, just random food data. OK. Now we are going to, like I said, again and again, I'm going to repeat this. What you're looking at right now here is the transactional or the row-oriented store. As we speak, this data is being synced into the analytical store. OK, and what I'm going to do now is run a cell which is going to read or access data from that particular store. OK, now let me quickly run this first, and then I'll talk about some of the specifics as time goes. OK, so pretty much the same thing which I was doing earlier, right? So this is, so if you notice, this is, the format is cosmos.olap, right? This is because we are doing reads against or accessing data from the analytical store. OK, and this is just account specific information and blah blah blah, right? So once this finishes running, which it you will see that it simply displays the data for now, right? So this is the data within which has been synced as we speak from your MongoDB containers all the way to the analytical store, right? So all these 500 odd rows right here. Now pay attention to the, if I were to scroll down real quick and run a quick schema analysis, right? Going back to the conversation we had about, or the discussion I brought up about the full fidelity and well-defined schema. And just notice all the data types here, right? String, long, blah 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 blah. And if you were to look at timestamp, it is a float here. OK. Now let's, this is just a very simple aggregation, but notice how we are doing this. As I mentioned earlier, I am actually working with the item property within the analytical store. But see how we actually use the column, because the column name, like I mentioned earlier, is appended with the data type as well. So if I were to scroll up, if you see that the item data type is of, it contains string data, right? That's the reason why it says that, hey, group by df dot item, and we append a string here, right? And this just does a very simple sum, but this is good enough for the purposes of the demonstration. Okay, but yeah, and just so that you could you could work with get away with not explicitly mentioning the data types, but this is not something which is recommended. And this is something, the next section is something which I've already sort of alluded to during my presentation, right? So right now it is float, and we'll see when I run the next notebook so this is all about, like I said, the full fidelity schema, which is a default option. Okay. Now, if I were to scroll back, and this time I'm going to insert more orders, but now notice that this is going to be the timestamp instead of being a float. Now I'm going to treat that as a string here, ISO string format, right? So this is how it is done. The rest of this is just a format, and it's going to be inserted as string data, okay, within Cosmos DB. Everything else is the same. So let me run this real quick. We have about 9 odd minutes, but I should be able to get through this. We have been pretty good on time so far. So all right, so finished creating 500 orders. Now, as we speak, the data must be getting synced into the analytical store, but we can try reading that now and see if the data has refreshed. It might take time, but let's see if it has indeed refreshed. So yeah, let me try that once again. Excuse me. Sorry. Yeah. Okay. Okay. Yeah. Now it's there. So now that the data has actually gotten synced into the analytical store, you notice that the timestamp right now has 2 data types. One is the float data type, and the other one is the string. So right now you have entries within your MongoDB collection where different entries have different data types for this timestamp attribute. Okay, now this is the beauty of what I mentioned, the full fidelity schema. Okay, now if I were to run this, just to make sure, right, run some queries and to see how it actually works. So if you look at the Spark SQL query, it does a select some. It is using price.float64 do count star for pizzas, where timestamp is string. Now we are saying that, hey, only select. This is a criteria for only selecting entries where the timestamp is of string data type. Okay, now this is all good. If I were to scroll down, in this case, we are going to select data using the entries only which have float64 as the timestamp. So let me run this, right? Okay, so if you see, it has about 114 entries where it has float64 timestamp values and about 99 odd entries, 99 entries to be exact, where the timestamp is represented by a string data type. Now, obviously, when you go back and run this, this is going to be random, because if I scroll up real quick here, here again, if you see, this is just randomly generated data. Okay. All right, coming back here now. If I were to run this last cell once again, so just to compare both timestamps side by side as well. Now, this is what it looks like, right? A float64 timestamp versus a string. Okay. Now, you know what? I can hop back here as well, and if I'm lucky enough, maybe not, but we can look at least one of the entries, documents within the collection. Sorry, I clicked on refresh, and this is taking a bit of time, but Yeah, you know what? Oops. All right, we're going to skip this. No problem. You can always follow the instructions and double check that it is indeed what we are saying it is. Okay. So yes, this is just a few closing thoughts that how the full fidelity schema support within the MongoDB API lets us use two different data types for the same property, right? But from developer perspective, it is really two different columns, because that is exactly how it is stored within the analytical store, right? So it is that handling is there for you, that is taken care of. Like I said, timestamp.float64 versus timestamp.string, right? So that's it. That's it in terms of a quick walkthrough of the MongoDB API and how you would potentially use that within Synapse Workspace to ingest data and then query analytical data, which has synced from your MongoDB collections back to your analytical store. So we have about 3 or 4 minutes. So I'm going to wrap this up now. And what's next? Like I said earlier, that's it. That's all I have for you in the space of about 60 odd minutes. I really encourage you to go through the rest of the samples and repos in those official notebooks, which I mentioned. I'll actually open that. I have this window right here. So if you see github.com, Azure samples, again, this is available in the live Q&A, so this is not going to go anywhere. So this has rich examples end-to-end for scenarios like IoT, IoT scenarios, retail forecasting, something which we went through partially, as well as the e-commerce food orders for the MongoDB API. And again, I do want to highlight one of the use cases which I think a lot of users and developers would be interested in is running these machine learning scenarios like anomaly detection and so on and so forth, right? Using Azure machine learning. Okay, now you would, I know, love to continue at your own pace. There are resources and links available here. And as I mentioned earlier, I am going to enrich and add on to this particular guide as well, make some corrections or add some more resources for you. So be sure to revisit and check it out later. All right, thank you so much for your time and attention. I think I have about 3 minutes, and at this time I'm going to stop sharing my screen. And I don't think I have enough time for questions, but I'll check the live Q&A real quick here. All right, thank you. It was awesome. I appreciate it from the anonymous attendee. Thank you. Yeah, all right, awesome. Yeah, so I see that the links are here in the live event Q&A, so that should be helpful. I see a question here. Yeah, the recording will be available. All right, cool. I am going to close or just maybe. Yeah, it is in a way. Yes. So Synapse is data analytics. Is it like Synapse? Is it data analytics like Snowflake? Yes, it is. It is similar to Snowflake. Yes, that's the short, really short answer. Yeah. So with that, I'm going to. I don't think there are other questions, but feel free to reach out to me on Twitter, on LinkedIn. So if you can, if you can help, posting those links here, that will be super helpful. And yeah, I see Emma has already posted them. Thank you so much. So yeah, please feel free to reach out to me on Twitter or LinkedIn or any other platforms where you might be able to get hold of me. I appreciate your questions and feedback and inputs. So thank you so much for your time and attention. I really appreciate it. Take care. Bye-bye.